Okay, so we are to group 5 the advanced school. So we are going, Marion and I, Maxime, we are going to explain the different topic of today, the experimental setup, the literature study, and then the next steps we are going to do during the next weeks. And sorry for the other group members who are still at school to handle the experimental setup. So yeah, the experimental setup is divided in 2 experiments, and then the next step is of course the experiment and the planning. I'm going to develop that after. So on the literature study, of course we are still working on it because the advice document, the report will be in 8 weeks actually. So we're still working on it. And as I said, teachers still need to correct some of our mistakes. What we learned from your data actually, in your compost, the NPK ratio are 3 to 5, and we found out that the general compost used by the general household, its ratio should be equal, so 5, 5, 5 for example, or 1, 1, 1. So that means we need to enrich the compost in nitrogen and potassium and phosphorus, for now, if you want to have the balance of ratio. What we found out in the chicken manure that there is a lot of phosphorus, and thanks to your data we didn't find nitrogen, but we need to investigate that because maybe they didn't actually looking for the nitrogen. So maybe there is, but in the data we've got there is nothing writing on it. And in the wastewater, the data you give to us, there is only nitrogen and a lot of heavy metals. So maybe that could be a problem for the experimental setup. But that, until now, that's good. In one you've got phosphorus, and in the other you have the nitrogen. So if we mix both together, we can recover the phosphorus and the nitrogen at the same time. So it could be nice to mix the 2 side stream. And we also study some of the alternatives, like the cyanobacteria. So it's just you grow cyanobacteria with the mixing of chicken manure and wastewater, and then the cyanobacteria take the nutrient from the mix we made, and then we just need to put the cyanobacteria directly in the compost. The other alternative is the vermicomposting. So you just you put some worms inside of your compost, and the worms, they're going to digest the compost, and by pooping they are going to enrich the compost. But the solution we decided to choose is the lemna hot dog. Maybe you already heard of something about that plant. It's a plant we grow on generally in pound. It's very tiny thing. It's like the one on the right. It's very, very small, and it's grow and it's uptake the nutrient inside the water, and the lemna take a lot of nitrogen, phosphorus. So it could be nice for recover for enrich the compost actually. So that's we've made a lot of alternatives in the literature study, but we found out that the lemna is the most useful for us, I guess. Mm-hmm. So that's as I said. So we are going to focus on lemna. Of course, our goal is to enrich the compost by using the side stream, so the chicken ashes and the wastewater. And we also investigate the roadside grass, but we are not going to do any experiment on it. We find in the literature study two applications on the roadside grass. We can digest them to make out of it gas, like methane. And we can also do like pellets to burn it afterwards, like biofuel. You can say it like that. Do you have any questions so far for the literature study?
Of those for the roadside grass, I'm very interested in the lemna thing. But for the roadside grass, are you only looking at energy?
Yeah, because there is a lot of heavy metals again in the roadside grass because
there is.
Yeah, we found out in the literature there is too much heavy metals to feed the animals, for example, or to put it in the compost. It could be like harmful for the plants. So
well, most of it is composted at the moment.
Yeah, but you told us that if we compost it slow down. If we put too much grass on it, it's going to slow down the process.
Yeah, I know, but you said it's not good for your compost because there's heavy metals in it. And I said, well,
Yeah, you still use it.
and I think you have to be a lot more creative on this side. To burn the roadside grass is a waste of valuable materials. I think. Digestion of the roadside grass. Of course, I'm interested in it, but I sent you a couple of reports, and in those reports you will find that it's not easy to digest.
Yeah, it's not easy. But with the by
And with not easy, I actually mean it's almost impossible.
okay. But if you do the pilots, the granules, actually you can sell it. You can sell it, so it's you can make an extra money out of it.
Yes.
And for example, you can sell it to the factory close to your place.
Yes, I agree, but I
what you
much rather like to use the fiber material from the roadside grass and make wonderful cardboard boxes with it, or fiber enforced materials, which is, I think, of a higher value.
Then the buildings, yeah, true, could be, yeah.
Yeah.
Okay, so yeah, we are going to re-edit our
Yeah.
search.
It's
Okay.
more where we stand for
Yeah.
in the there.
Okay. Okay, we are going to investigate that more deeply.
Yeah.
And we'll see
Please,
what we found out.
Yeah.
It's good that you say that because we can change our way of thinking.
Yeah.
Okay, so more fibers to make like board and
Yeah.
okay.
And maybe look at the composition of the roadside grass, and I think the amount of heavy metals is not
It's
too
not
much.
that much, yeah.
And if you can separate the different fractions, then maybe some of it you can use for digestion, and some of it you can use in another way.
Mm.
Maybe it's not either you do this or you do that, but maybe you can do this and that. How do you say? Maybe you can do both.
Yeah, you can do both, yeah.
And then you, you can really create value.
Yeah, okay.
And the lemna, that is
It's a plant actually.
It's a plant.
It just floats on the surface of the water.
Yeah.
There's like a root, and
Yeah.
the root uptake the nutrients. And it's got
Yeah.
the capacity to grow
Yeah.
very, very fast.
Yeah. I know. I've done a research project on lemna because it's in the freshwater
Yeah.
lakes in the Netherlands. Sometimes it's a problem.
Yeah, because
You have to take it out.
Yeah.
And I looked at digestion of the material, and it was digestion was not the way.
No, that just is not the way.
But so therefore, I'm really interested in that.
Actually, what about the Domo? Want to use the lemna? It's another project group.
Yeah.
So you know that.
Yeah.
And they want to recover the lemna, and we want to use the lemna to uptake the nutrient from the side stream,
Yeah.
discuss to investigate, and then we want to put the lemna directly inside of the compost
Yeah.
to
Yeah.
mix
Yeah.
it.
Well, I'll also think when should you do that? At the beginning, at the end, or afterwards, or
I think we're going to running out of time to see that, because first we want to see if we can grow lemna. I'm going to speak about that later on the experiment. But we want to see if we can grow lemna out of the side stream, because maybe does it work? Maybe
Mhm.
it works, and if it works, we'd like to see if it's very efficient or not. And if we've got enough time, we can try to see where in the composting process we should introduce the lemna. but I'm really not sure if we can do it until the end of the year.
Mm-hmm. Okay.
So this is for the literature study actually.
One of the problems at the end is phytosanitary. Right. When you put at the end at compost, you have to get back temperature into compost. So phytosanitary, it's a problem. Putting plants back into compost.
Yeah, maybe the better could be
Yeah,
at the
can
beginning.
be. Yeah, there will be people that say that there will be diseases in the plant that also can affect on the crop growing afterwards.
Okay.
So yeah, you have to make an
Pasteurization step.
Okay, yeah. Yeah. Yeah, we need to investigate that.
no.
So for the experimental setup, we want to do like 2 experiments for now. Like the first one will be only to see if we can grow lemna out of the wastewater, because the wastewater have a lot of...
You want to produce lemna out of the wastewater?
Yeah, to grow the lemna with the wastewater, but with different range of and concentration. We want to see if it's possible, because the wastewater, we see that there is a lot of heavy metals inside. So we want to see if the heavy metals are not too harmful for the plant, and if it is, we need to find a way to remove the heavy metals before to grow the lemna. It's just a control test actually. We want to see first if we can use the lemna, if we can use the wastewater to grow lemna, and only wastewater, and then we want to see also with the chicken manure ashes it's possible to grow lemna. And that's only 2 beaker glass, let's say like that. And then the second experiment, we got like 20 beakers, and we want to find different concentration of mixing the wastewater and chicken manure ashes. Plus, to see if we can have the good range to grow the lemna, because we know the lemna need a certain range of nitrogen and phosphorus to grow, and we want to see which one fits better to the lemna actually, by mixing the wastewater and the chicken ashes. So we need to investigate different situations.
So you're not concentrating on getting minerals from the water or the ashes, but you're trying to grow lemna.
Because the lemna can take the nutrient, the nutrient we need nitrogen and phosphorus.
Okay. And in that way you want to add
To ending in the compost enriching. Yeah, enriching.
Okay.
We know it's a different way by the other group.
Yeah, it's creative. And if it doesn't work, then you have not so much to show. Then.
Yeah, we know. We already discussed a lot with Jaco about that, and he said even if the experiment failed, it's still like a result. You know that you can definitely delete lemna. I know for us it's not easy to take that choice, because we also know that it's possible we can fail. But of course we're going to do how possible to make it worse.
Yeah. Okay.
But we really want to investigate that way, because we know the other team do like a more chemical way.
Yeah.
So we try to find a way more, let's say, friendly.
Yeah. Okay. No problem. And as for Jappe, I can understand. If he says no result is still a result. As for me, no results is
No results.
no result.
Yeah. We know there is like a risk in this
Yeah.
kind of experiment. But also the cost can be less expensive, because with the chemical way you need to add a lot of chemical. I guess I didn't investigate their production could be,
Mm-hmm.
and this one is more easy.
Yeah.
So of course we depend on the result at the end.
Yeah.
Okay, that's it for the experiment. One question on it. This morning, because we beginning the setup of the experiment this morning, we discussed a lot with Jaco about the concentration we need to find because of the heavy metals, and also the chicken ashes to collect the concentration of phosphorus. We need to measure when we have the sample to see how much is really inside. Even if you give the data, we need to be sure. So we've got a lot of concentration dilution to do, and we're also going to do like Duplo in order to be sure if one beaker fail, we are going to do the same beaker to be sure it's not because we failed the first one or something like that. So all our experiment will be in Duplo to like a control test.
Yeah.
And the first part of the experiment will at least take two weeks, and then we will see which range, which concentration is the better, and then we are going to focus more on the which kind of range the lemna can really like enjoy it and uptake maximum.
Most,
Yeah, the most. And if we got the time at the end, we will try to dry the lemna, to put it in the compost and see if we really got an enrichment in the nutrient. So that's it for the experimental setup. And then for the next steps, we already explained the current situation, so we're still working on it. And the experiment will take us like 7 weeks, 8 weeks. So we've got a lot of time to see how it works actually. And we still have some doubts about the heavy metals because there is a lot of cadmium or mercury, a lot of things could be harmful for the plant. So we don't know if the plant can really grow on it.
Mm-hmm.
So if we see that in the next 2 weeks it doesn't grow, we need to remove the heavy metal first and then grow again.
Yeah.
And we're also going to investigate the different situation of the mixing to be sure nitrogen and phosphorus are in good range. And after we're going to analyze the result to put it in the FRS report. But also for the literature study, even if I told you we will send it to you at the end of next week, the first draft we've got, we still need to investigate a lot of things because we need to learn more about lemna, the mixing, because we also need to know some things about the low because we can't really mix the chicken ashes like that. We need to find a bit more like the low, and also the phenioascus and the fibers of the vertical grass.
Yeah, yeah.
Because we need to change our way of thinking.
Yeah.
And I guess that's it. So do you have any questions?
No.
So far?
So far.
Because you already asked a lot.
Sorry?
You already asked a lot of
Yeah,
questions.
yeah. No, okay.
Yeah, I've got one question actually.
Yeah.
Because you can provide us the wastewater,
Yeah.
but we would like to know if you know the temperature of the wastewater. Like if you've got an average of it's always like the same temperature outside or
Like temperature outside.
the water is not hot when it get out of the compost. It's not warm by the compost or
Well, it's not only that water, but it's also rainfall what you get. So it's a combination
It's
of
mixed.
rainfall and the material that comes out of the organic matter.
okay.
So it's bad when on this moment it's difficult to get only water out of organic matter because that's only in the winter time. So from half November until end of January you get I can give you water from that's only coming out of plants.
Okay.
That's on this moment that's not possible.
It's a problem for you that there is a lot of rainwater, or for you it doesn't change anything? When it's rain a lot, for example, does it change something for the composting process?
Putting it back, we don't look to that on this moment. So when we put backwater into compost, that's your question, or what's your question?
My question is more like when you got like heavy rainfall, it's a problem for you for the process. Maybe it's I don't know, it killed the bacteria inside of the composting process. If you got
No.
too much rain.
In compost, in the process, you need water.
Yeah, you need water or moisture.
Moisture.
Moisture, yeah.
That's what I explained. I can give you numbers for that. What's optimum for so much water on that moment? That there is no optimum. It depends on how much material you have in the composting
Okay.
heap.
Okay, yeah. I understand.
So when you outside, so as I am composting, when you're outside, it's so as this.
Yeah. Okay. Say that.
You can
If it's raining,
change.
it's raining.
It's raining, it's snowing, it's snowing.
Yeah.
And,
It's getting wet.
Yeah. Okay.
Yeah.
But for you, it's not big deal. There's a lot of rain or no rain.
There's no problem.
It's not a problem. Yeah.
so,
So I guess that's it.
Okay. Thank you.
Yeah, you're welcome. Thank you for receiving.